Thank you very much. It is awesome to be back here today. I actually used to work in this building, it's a little bit about me. I'm a consultant today. I work with banks, mostly regional and sort of old, like very rich banks with rich histories. I've come here by the way of Capital One, obviously, Amazon, and PyData. I was also the original chair committee of PyData that happened here about 2 years ago. So that's kind of me being a egomaniac. So today what we're gonna talk about, I'm not gonna, this is not supposed to be a very technical talk, but the idea is to sort of go through the thought process and sort of to come up with a few things that we can take away that apply from a technology and from the open source adoption perspective. So why do we talk about AI today? There's a few things have happened. Explosion of data being one, which is 90% of today's data was essentially created in the last few years. We also have the advent and sort of the journey that open source has taken, especially in the scientific Python world. There's the cloud computing and the DevOps as emerging fields. And one quick note on the infrastructure automation. At most of the banks that I've been to, I've never seen any place which has achieved better than 5% hardware saturation. So that tells us that a lot of banks have a lot of hardware, and it may not be used for any analytics. So, combining all of this, we are just set up to have a conversation of trying to build an artificial intelligence or a brain that can govern how consumer lending works or consumer banking works. So, from a very high level, when we talk about these types of use cases, there's a few things that everyone will come up with in the context of AI. Everyone is going to talk about chatbots, the voice assistants. There's a compliance and regulatory sort of insurtech and fintech companies working there for KYC, know your customer, anti-money laundering. There's model management of regulations there. Then there's a marketing and a decisioning bucket, which has credit risk, your sort of rank ordering model, personalizations around who needs what, and recommendation and sort of just self-heal of those types of decisions. The interesting part here, which I want to call out and is the basis of my argument today, is that we have different types of use cases, but a few of them are non-proprietary and the other ones are proprietary. What do I mean by that? By non-proprietary, I mean that any other bank can to get this capability, either to build it themselves or to buy it, but it does not add to their competitive advantage in the long term, in the long run. The orange boxes are the ones that are essentially being built upon by the data that these banks have. So your customer data, which is proprietary to the banks, no one else has access to that. You can essentially build out these types of use cases with them. So those orange boxes, to me, are the competitive advantage, while the rest is sort of, over time, will just become status quo. So now that will just set us up to talk about the banking data flywheel. How does that come in, and what is that thing that banks are trying to do, which can benefit from an automated, intelligent agent? So we've just started off with the data. The data, again, we have the proprietary nature of it and non-proprietary. On the proprietary side, this is all your product level information that the bank may have, my customer relationship information, that, hey, I have a credit card with Capital One, and I have a mortgage with Chase, or other types of things, or where do I spend? All these proprietary things that are informations that only the bank may have. The bureau data, anyone else can actually purchase it, so it's not your competitive advantage. That turns into analytics, and historically in the banks, a lot of these analytics have happened from off the shelf side. And what that means is that you can essentially take it and convert into your own proprietary ideas around unit economics and segmentations. And we'll talk more about these. Then the next step becomes the decisions, and in there you are essentially looking at targeting, which is something that you will that the bank knows. That will hopefully give you growth, and that growth gives you more data, which will give you improved models, improved strategies, and improved testing. And we cannot leave out testing because that is another aspect of it, which will make this this data flywheel churn. So now we have just set it up in a way where we have this growth flywheel and would like an intelligent agent to basically churn this as fast as we can, and that becomes the brains of our sort of consumer lending problem space. Similarly, on the analytics side, the important things or the brains that are powering this is essentially segmentations, which is how would you rank order different types of customers. So as an example, I go to CapitalOne.com, apply for a venture card, and I get a line and an APR. All of those things are specific to me, or I fit some criteria that enables the bank to make that decision. So our point is that everything that we are doing from an analytics side and this data flywheel is powered through these just segmentations and unit economics that the bank has. And these two things combined is that brain that you may need to automate or make it intelligent. Now, we also have some restrictions and constraints that are not available everywhere else. So let's talk about some of them. So as a bank, you are a regulated entity, which means that you have to comply with the laws and acts. So a fair housing one as a big one, equal credit opportunity, unfair and deceptive practices, etc. What they are essentially doing is making sure that everyone is the decisions are equitable and fair. The second piece, which is also unique to the banks, is delayed outcomes. In my example, if I get a credit card with $5,000 credit line today, the bank may not know my performance and how worthy am I until there's some amount of time that has passed. So this is very different than optimizing your conversion funnel in retail, for example. You still you do not know or you don't have the ability to get the rapid feedback. So that means that all of the system from a data perspective has to be set up in a way where you are getting that long-term feedback and allows you to correct your business over time. Governance essentially means that everything that you do has to be auditable and it has to be transparent, hopefully reproducible as well, but we don't have to go there. So what that means is that going back to our original point, we are trying to build out this brain for this flywheel, and we have some constraints. So now let's talk about the actual building out the brain part. So how do you make these types of lending decisions in the first place? So at a typical consumer sort of lending business, you would like to view your population or your prospects, which includes everybody in this room, would be from a perspective of the lifetime value, the cost that it is to acquire such a customer, and then the product terms that you are giving them. So based on these different sort of combinations, you will come up with a different sort of criteria to evaluate, and that the criteria is in our example, an NPV, the net present value. All it's saying is that you have a discounted cash flow, and you're projecting it out, and you're getting some type of value, and like this allows you to have differentiated treatments across everyone. So now there's an interesting aspects that like we have a grid by like 10 by 10 by 5, and like we've come up with like these number of boxes or like these number of different treatments. We don't have to be constricted to a 10 by 10 grid as an example, so you can actually get personalized, and like that's where AI has this advantage that like now you can build out these types of decisioning frameworks and these models that will allow you to make a much better or more granular decision. So in our case, we have the purple, yellow, and red, and we should definitely market the purple ones. We may want to do the yellow ones if it improves the scale of our business, and we want to avoid the red ones. So like that's sort of the unit economics, and like that's the way most consumer lending businesses have to look at themselves to be data driven. And all of this stuff at a typical bank is just done with an Excel-based cash flow, right? So like you would essentially have these, line items, and you have your business, sort of like how the business works from the setup perspective, and then it will project out the value of a particular type of a customer. By the way, this was the just sexiest way anyone has ever just set up a Excel slide. All right, so now we're not if human beings are the biological bootloaders of AI, Excel is the way to do it. All right, and it's like, you basically come up with this, and you will have all these Excel sheets. So like, let's say at a big bank, you have like 1,000 segments, and you have like thousands of these decisions that you are tracking every time you've changed something, and then you are also making sure it is auditable, is transparent and such. So in this case, I want to say 2 points there. One is that we have some kind of a calculation that is meaningful to us to understand the business. The second one is that it is an inherently human in the loop type of a problem. So you need humans' input to either make sure what we're doing is fair, or to make sure that the proper inputs are provided to the system. So now we are in this space, and like we have a lot of data. We are in the phase one where we understand the economics of our business. Now let's take a little bit of a segue and talk about the billing data and what is actually the reality that is on the ground. So what I'm showing here is a COBOL copybook, which is essentially how most of the billing data that I've seen at all banks come in. It's a file format with this like weird tricks, and all of these things are essentially going into like mainframe. So like that's the type of data that is the most important one for you to like get the unit economics, because you want to know how people are paying, when they're paying, and then what type of activities are they performing on your product. So the billing data, which is again comes from old school, like if you have ever had a credit card application, and like that income statement or that statement that you may get is exactly what you see in a COBOL copybook, and now you have to like parse it all and like make sure it's in like some way that is usable, and you don't have to like basically learn COBOL, which I ended up doing earlier in the year. I did not really learn it, but whatever that means. And if you are still not like 100% like convinced that it is the case, like I've pulled that last night. This is software engineer for COBOL and like DB2, and I think someone up there may know all the other ones. But so like, and it's like estimated at like, about just six-figure job. So it's a real thing that like banks are going through. They got a lot of technical debt on this very important data that you absolutely need to build out these brains. And like all that stuff is in COBOL with like null is actually like a zero or actually zero, like the written out term. All right, so we have, we took a little bit of segue. We know a little bit of our challenges now. And we have a lot of data. We are, doing these Excel models, and we're in a good place. But now we have a lot more data, a lot more customers, and we want to get more sophisticated with our unit economics model. So what's the second phase? Now we go to the model-based systems. And in this case, what we're trying to build is a system that is still, governed and transparent, but all of its inputs are provided by the model. So the model is the ground truth for that system to implement, to come up with the output value of a segment. So going back to that Excel sheet, okay, so how do we do that? How do we make this more scientific and better from like the data perspective, and then get more granular to like have better operational scale? So this Excel sheet, if you just think about each of its cell, it's essentially some kind of calculation that is dependent on like something else, and there's some raw input. It will look like something like this, right? So like you have like empirical drivers, the blue boxes or the blue nodes, which are your actual models, and then you will have some intermediate calculations, and you'll end up with the total revenue and expense. Then you can add your marketing, and then you will get to this like end purple metric that you would want to decision by, and like that metric could be anything. It could be NPV, it could be rate adjusted margins, and so on. Now, to notice that the ground truth is essentially defined by these blue empirical drivers, and like would like to model them. So once they're modeled, we will essentially put that in, and we have this like giant Excel sheet that on each little change, everything recalculates. But we don't have to do it in Excel anymore. We can actually do it in a way that is that actually uses our abilities to synthesize all this data into like nice models that can govern. So like now we are, okay, we got the Excel model, we got the brains figured out, we actually figured out a way to like, to provide these things and like make it very data driven, and you have some data science like problem. The third phase is the planning and optimization. So you have basically done all this work, and what do you want to do now? So in our system, all of our assumptions are explicit, and they're provided as models or as numbers. You take those, and you have this like unit economics calculator that defines your business, and then you can optimize by actually using scientific or like studied optimization techniques like ILP or others to come up with multiple or multi-optimization, a multi-variable optimization problem. And that optimization problem is part of AI, and the sensitivity to gaming box up top is your planning, which essentially says what happens if there's a recession scenario, what happens if our employment goes up or goes down. So like those types of planning and optimization, you are essentially trying to build up those problems and express them as a system that can actually perform these optimizations. And based on that, you would then have some outputs, which are your decision policies, and you have some historic data, and you would have a need to make sure all of your inputs and your assumptions are actually safe and are holding. So going back to our data flywheel, what we can do now is that we can essentially come up with a new segmentation every time, or if there's a change in our cost of funds or any of the economic variables, we can then re-optimize and have new decisions and essentially make this process faster and faster. We did not make an agent that is autonomous and like making its own decisions, but it is helping us to build out the decisions in a way that is still governable, and there's some ethics and fairness criteria that you can meet. And like this is a real dependency diagram coming from a real world credit modeling blog post. And here is like what these types of calculations may look like at scale. So you have this like orange box up top, which is or the orange node up top, which is your original pandas data frame, and like that gets distributed out, and you have all these calculations and these variables, and like you are essentially then gonna get synthesized out to a smaller output. But this in itself is the system that you have to build and really understand very, very well in order to operate it at that sort of have some brains to like run your decisions. So now we're going to get a little bit more around technology and like why this is a PyData talk. So there's some critical observations. We had this Excel sheet, which is basically a DAG, and we have humans in the loop. And we need to solve this problem, and like we really want to be able to make the system that expresses those constraints. And there's also regulatory stuff there as well. So what this looks from a technology perspective is that you may have some access to a cluster compute, and like you don't need a lots of scale to like get started, but that has the raw data. The raw data is just like the COBOL copybooks that you can then convert into ASCII, and then that will convert into and then you can experiment with that. You have these tables built out, or all these drivers. There's some like collaboration. And then you will have a decision that is deployed out. All of these things, and like this whole workflow is 100% answerable through PyData or scientific Python libraries. So we'll look at the first step of the task graph. So with the Dask, which is a parallel computing library in Python, if you guys don't know about it, please to check it out. We'll let you to provide you a way to like basically to define these calculations as a nice task graph. And this task graph has properties around you can essentially traverse through it, just sort of topologically, and then get the actual dependencies to persist all across. So Dask has that answer of converting your big giant Excel sheet into this calculator that can then be scheduled from a local computer to a distributed computer, and it also takes care of some interesting scheduling problems there too. So like that's the first answer. The second one is on the human in the loop. And I've been recently working with Interact tools and Jupyter Hub. Interact allows you, or like provides you these like building blocks that you can essentially take a Jupyter or IPython compute environment and allow people to play with that, which has awesome collaboration properties. In just some ways, the Jupyter message spec is the new API for data processes. To me, that's an interesting way to think about it, because you are essentially building these like web apps with like interaction, and that interaction is provided by the Jupyter kernel. So Interact tools and the Jupyter Hub will essentially play the role of creating those like unique workflows that you may need. There's sort of data-heavy workflows, but to appropriately to capture that insight from people, from the humans in that loop. And then there's also, going back to the picture, if you have a Hadoop cluster, which is very, very often the case when I go into banks, the first thing is to basically there's a library called Skeen, and Jim Christ had an awesome talk on it yesterday, which will allow you to essentially work with Yarn and Hadoop technologies. And then you can use Dask on top of it. And then you can have some Jupyter and Interact type of workflows for collaboration. So that's I'm obviously simplifying a lot of these things, but at the very high level, these are the building blocks that you need in order to create and maintain this brain that will let you make equitable and more profitable decisions in the future. So in the final thoughts, there are a few blog posts. I'm going to tweet this slide out afterwards, and please check them out. They have a lot more detail on how this could impact your work. So I gave you guys an argument where I made a bit of a leap on the technology and the implementation side, but the argument is that we have a bunch of calculations that have to be carefully done in order to drive these decisions. They're motivated by a lot of regulatory and compliance issues, and you then want to be able to build out this system that can scale. And from a technology side, we have a smooth answer that is available in this community. Any questions? Yes. So the question was that we have delayed to express this task graph. Could we have used futures for real-time task scheduling? Yes. In our case, we know our task graph beforehand, so it's not dynamic and it does not need to change. So you can just use delayed, but to where you have real-time streams and that type of a concept comes in, futures is probably going to work. I have not used it because I have not had to deal with that exact problem.
Can you talk about the multi-objective optimizations and basically how you got stakeholder buy-in from the business, and then how you validate that you're actually taking some optimization towards their objectives and balancing with everyone else's?
Yeah. So the buy-in question was, I think, we basically wanted to provide another tool and not the final answer. So this optimization result is not that you will actually want to use, but it's a helpful way to make sure that the business's judgment and their intuition is aligned with what the data says. So you have to essentially provide them lots of different types of constraints and different types of options, which is essentially how you will game and look at scenarios and their pros and cons. In terms of just setting up this, it's an ILP problem because you have integers that you are optimizing on. You have a credit line or you have a loan amount, and your constraints are essentially multivariable. So you are as an example, you could have a constraint that each cell that we saw in the cube is NPV positive and less than X% of other metric, and eventually the solver problem there are plenty of solvers which are available and are capable of solving that problem pretty quickly. Did that?
Yeah, that's great.
Great presentation, thank you. How do you think about interpretability of more complex models in the banking world?
Yeah.
And
So-
more specifically, both local and global.
What was the last one?
Both local interpretability, so every decision, whether you approve a customer, I think that's relatively well understood. The global interpretability could be more challenging, I don't know.
Yeah. So the global one is exactly what we're trying to answer from this system. That I can perturb something as my inputs, and then I have an output that I can essentially look at across like various options or like some kind of surface. The interpretability here, like our forecasting drivers is a forecasting problem. So you have like a time series that you're trying to forecast out. So like in most cases, I've been able to get away with just like linear modeling techniques. And like that's appropriate for this because you want to kind of make sure that everything is readable and like the weights mean something to you. However, you can define your segmentations in like whichever way you can, and like there you may want to use some like more machine learning or like less transparent approaches. And the main criteria that you have to be aware of is that there is adverse action reasons that you have to provide. So like any of the decision that your model is creating, you can to tell people why that happened, and like that has to be explainable. So you could do that with gradient boosting machines. You can do that with the linear models. I know some people have actually tried doing neural nets to like to get to a place where you can still get the answer on like what happened, but it just becomes more and more complicated. In our case, we're generally happy with trees, like gradient boosting type of techniques, and then having the linear regression for forecasting problem. The global impact of it is very hard to do without such a system. So like that's one of the ways how you will sell that is like, okay, now you like change the model. You had one version that you change, your whole system change, and then you can at least observe the outputs, and then also have some kind of trace to like look at what happened. We don't have a great answer on the global optimization because that's just a hard problem. I have seen some people do partially sort of like Monte Carlo simulations to like partially known system that you could do it, because in our system, the way we define it is exactly known by the models.
So, do you happen to know any bank that's using neural networks yet in any like decisioning system?
I don't know the bank. I know a lot of vendors who are doing it. I wouldn't recommend neural networks in production for the most part. It's just too much pain. Because you may not get the value back, because at like some point, like your techniques are not going to add more than what your data already has.
When you mentioned the Monte Carlo, was that in relation to trying to adverse action with some more sophisticated machine learning techniques?
So it's not for adverse action. It was more around what happens if you book somebody today. You give them a bigger credit line 8 months from now. How would that system or like those types of actions will have an impact?
Thank you.
Hi, I'm here. Hi, I'm here. I have a question about you talk about like multiple variable optimization. So those variables are discrete value or continuous variables. Like for example, it will be input of like credit line. Will it be just like 800, 1,000, 1,200, or it's actually a range of like continuous 500 to 1,000, like or 10,000?
It will be discrete, but like in reality, even if you just use the range, your answer will be very, very close. So I don't exactly know how much of a value do you actually get to get the exact answer, but it is a discrete problem. So if you want to just solve it that way, you have to use integer linear type of programming to like get the optimization done.
So besides credit line, like what about like APR or other things, or all discrete values? And then how close are the intervals? Like for example, credit line. Because I just had a very weird experience with a Max card. I got a like or Chase. Now before they always have this very rounded credit line like 2,000 or 3,000, but now they gave like 2,200. So what is like the intervals right now with like the big companies you worked with?
Like the interval of your credit lines?
Yeah.
Like how, I think that's mostly governed by like how your operations are set up. Like I've never seen a constraint. We usually try to keep, nice round numbers. But I have not seen where we have like 2250 credit line or something like that. But I have seen weird numbers every once in a while.
Yeah, because when I got those credit line, I thought the model is more like continuous variable input rather than discrete. That's where my question come from. But so
your linear model would take the continuous input, so like that's the drivers. But when you are trying to pick a line, you would want to pick the exact line. So it's like that's on the optimization side. We can talk more after.
Okay, thanks.
Cool, thank you so much.